Hello Internet, welcome back to our grass render. I've changed a few things. This is a little demo that I kind of put together, and we're going to be kind of extending this. So what we're going to be working on today is physics in our grass render. And the way we're going to do that is we are going to use a compute shader to actually physically simulate sections in our grass. And so the way this works is I have a texture. I can actually show that to you. And so like we did last time, we had a orientation map that kind of said this is the angle that this grass instance is facing. What I've done is I've created a grass physics script and a grass physics compute shader. And that actually takes it and calculates this. So this isn't updating in real time. That's just Unity. But what this is doing is it's actually every single frame, it's actually moving this across our texture. And so that is then bound to our material, which is why you can see the grass moving. So normally you just shift the UV coordinates. We're actually moving the entire texture. This isn't what we're going to be doing, but it kind of demonstrates the idea. So this map is actually going to be used to like physically simulate things. So the code is actually fairly straightforward. I got a little bit out of hand because I ran into a few issues, but I solved them with an easier solution. So we can drop some of this. It's not needed, but effectively what it does is, first off, it calculates, there's two things that it does. It flashes the input. So there is a normal texture input, like the textures we were using previously. That needs to come from somewhere. So that is actually being flashed onto a render texture, which is then used repeatedly over and over again everywhere else. So our simulation actually happens only on that render texture, and that just stays on the GPU. We don't need to pull that off. We can, so we can render with it, or like look it up or whatever. But for all intents and purposes, it can stay on the GPU, and we don't need to transport it back and forth or do anything like that. It's all on the GPU once we do this. So the entire physics is handled on the GPU. And so two things happen in start. We just set up all of these values. This flash input is not saved because it's only used here. The physics simulation ID is, and that's just the kernel ID for our physics simulation. And then we set the height and width, which is used to actually calculate the UVs of our texture. That's actually only used in this flash input step. Then we set the input and result textures. So result is going to be the actual output from our texture, and then the input is that initial one we want to do. And then we just run this. So this will run our flash input, which literally just copies a texture, an input texture, into the result. That's all it's doing here. And yeah, that's it. And so after that, we set up our result texture on our other physics simulation. So this just ties the result, that flashed texture, so that render texture now has that seed texture on it. Now we can actually put that onto our physics simulation and use that there. And then we just set up our material. So I actually set the material that we're using in our rendering. I'll probably move this out later. But for now, this deformation map is getting set so that our material actually sees this. Then there's a reinitialize toggle, so we can do that entire step again if we need to. And so that will just run through and do all of that step again. So if we want to change the texture, we have to just set reinitialize to true. It will reflash the texture and everything's good. Other than that, though, this will just loop. So it's part of the fixed update, which will be part of your normal physics simulation. So it'll happen a fixed number of times. That's configurable in Unity. I think the default is 60, but I could be wrong. It's not strictly relevant what the default is, but just making it part of fixed update made sense because it's part of physics. So this actually goes and just moves things. So these read-write texture 2Ds can't be used with your text 2D LOD. There's no overload for it, so it doesn't work. But you can just index into it. So that's what I'm doing here, is I'm just moving it one to the side and then just having a modulus so we don't get a out of bounds exception. And so That's it. That's all we need to get this working. Okay, that was weird. Did I change something? I can't unpause. Whatever. Unity's been being a little bit weird lately. But anyway, what we want to do now is actually get our grass to, I'm thinking in this video, just basic stuff. We're going to stand our grass up. So in order to get that working, we should, I need to check myself before I talk here, but we should be able to take, we have a point. I want it to get to some target. I'm thinking we can actually combine those two and divide it by some value, say 2. But obviously there's issues there. We'd want to use like a lerp or something in order to get it there. Maybe a slurp. I'd have to check on which is the best for that. But effectively we want to smooth between one to the other. And then we'll probably normalize it just to make sure. And then we should be good. Theoretically, these vectors will already be normalized, but it kind of helps when you're expecting normalized values just to ensure you have normalized values. Because otherwise things get weird later. Because in this, a small error will add up, because this is going to be happening 60 times a second or more, depending on how you set your game up. And because of that, you kind of want to check and make sure that things don't get off, because that small stuff will add up really quickly, especially with grass, because that's going to stick around for a while. So what we're going to do is create a result new vector. So let's pull out our current result. I don't need all of this fancy math. That can all go away. We just need to get the current pixel from our result. And then we're going to write our new vector out there. Our target is actually a new vector plus a float 4 of 0, 1, 0, 0. So this is just 1 straight up along the y-axis. And then I can divide this by 2. So theoretically, we just added 2 unit vectors. So we should have a length of 2. I can just divide by 2. Alternatively, I should new vector equals normalize, I think, of the new vector. And that will get us a normal of that. Okay, I don't think that's related to what we just did. So if I do this, it all stands up. So if I reinitialize, yeah, so that's super quick, but you can see it is standing up. So that's good. It's actually doing it. What we need to do now is actually not have that kind of smooth the transition between these two. So I think I may want to go and search for that, but just for my own amusement, this would be the current, and then the target would be float 4, 0, 1, 0, 0. So I'm just going to copy all of this here. We'll keep our normalize just for fun. And if I just do 0.01, I don't know if lerp is an actual function that exists, but we're going to try. Didn't throw an error, so probably. So let's reinitialize that. And there we go. Our grass all stands up slowly. And so theoretically, we can actually tie all of this to like a Springiness map or something. And so let's say you drive over grass with a car. That's going to stay longer than if you just like lightly walk on it. Or if you run through it, that's going to be somewhere in the middle. So what I'm thinking is if we can have some sort of springiness. That one's like going into the ground. I don't think that's right. Maybe. It's good enough for me. All right. So I'm thinking final thing. Wasn't really intending on doing this, but we're going to do it anyway. Let's add a sampler 2D Do I want this? Maybe. We're going to use just a normal texture, not a render texture for now. We may switch that in the future, depending on... I haven't figured out how I'm going to handle collision yet. That's still in the works. There's a bunch of weird ways we're going to have to think about doing that. So yeah, it's going to be interesting. So let's do a Springiness Map. And so white is obviously going to be maximum springiness. I don't really like that variable name at all. But the idea here is white. So from 0 to 1, it will be maximum springiness. So if it gets all the way down to 0, unless that's changed by some code somewhere else, that grass will never stand back up. But anywhere else, it will automatically, over time, move back towards the center. And that is going to be determined by this springiness map. So we're going to also need a float of the max springiness. That's just such a weird word. I don't know if I'm spelling that right. I have no idea. So what's the best way to do this? Public texture 2D Springiness Map, sure. Public float max springiness. We're just going to expose these for now, just so that somebody can work with them. And then, what do we want? Like a recovery speed, I'm thinking. Public float recovery speed. Yeah, okay. So, yeah, this should work. So our recovery speed is going to be, we're actually going to divide this when we set it into the shader. So 1 over our recovery speed is going to equal whatever. So by default, I can just set that to 1, for example. But effectively, if you set this to 10, it will take 10 seconds for it to get to the top, assuming the maximum springiness is 1. So this calculation is going to get way more complicated over time, but I don't know, I'm making it up as I go, which probably isn't a good idea. But oh well. Let's do this, set our texture for our physics simulation to our Springiness Map. I think I spelled that right. Sure. And then we also need to set the set float of the max springiness, I think is what we called it. And we'll set that equal to the max springiness. And then finally, we added that other one. Float recovery time. We'll call it recovery speed, I think. I don't think I've actually set this yet, so we should be good. Recovery speed. I've already used that variable, or I already used that name. That's good that we're agreeing afterwards. So let's do a float there. We're going to swap out this 0.01 with our recovery speed. We aren't passing in a time at all. I don't know if we can actually... So Unity does have like a time, but I don't think that comes into compute shaders. We're going to find out really quickly. And then what else do I need? Float springiness is going to equal our text 2D LOD at our springiness map with a what do I want? Yeah, let's do float for id.x divided by width, id.y divided by the height. That will give us our UV, and then the other two components can be zeros. I just use float fours here because it says it expects float fours, so I might as well give it what it wants. Let's see here, recovery speed times that. times the springiness. And then we just need to multiply the result we get out of our texture by the maximum springiness, which will scale it effectively. So assuming all of that is correct, it isn't. So time doesn't exist. We're going to need to set that. Float elapsed time. So we're going to swap this out with our elapsed time. We're going to pull that in from our grass physics. I'll have to set that down here. It should be roughly the same every time, but we don't know if it is. So we're gonna pull it in. And so this can just be the time dot fixed time delta, and that will just be the time since the last fixed update. And theoretically, that should be everything we need there. There's a few other errors, so let me check those out quick. Kernel index is out of range. Undeclared identifier, elapsed time. Move the S, there we go. That error is gone. Objects reference not set to an instance. Kernel index 0 out of range. I think we're good. I think those are just because I'm running it. So those other two should go away, if I'm correct. And we need to actually set a texture. So let's set this Springiness map to something. That looks interesting. So we should see like a cross appear, theoretically. If this works the way I expect it to work. Kind of. I feel like I took something out that I shouldn't have, because this isn't the result I expected. Maximum springiness. That would probably help. We have, let's set this recovery speed to 30. So it'll take 30 seconds for it to fully recover. We'll set the max springiness to 1. It was 0, so nothing would recover at all. I don't see any changes. So I'm going to say that may not have worked. Let's crank that down a bit. I suppose I could just try reinitializing. That should theoretically reset all those values. So if I click reinitialize, it should bring them back. Why is that so dim now? I may have screwed something up. I would assume it's over here. Our new vector, lerp by the recovery speed, which will be a small vector times our elapsed time, which will also be a small vector. And then we have our springiness, which should come from the map, which should be fine. Oh, this isn't gonna work. There, let's grab the red component from that instead of just everything. That didn't really make any sense. And let's reinitialize. No. Max springiness. Big. Okay, that wasn't what I wanted. Let's set it to something else. Maybe a default particle will work. Or this is the problem, is I don't actually know what. These are just like random textures that are part of this project because of other things that I've pulled in. So I don't know how well this will work. Or if it will work. That's probably not good. Well, it stood up. So I guess that's good. That means that it did actually work, so our texture must have been wrong. Yeah, so they kind of recover at different rates, depending on where they are. It's a little bit hard to tell, actually, just because of the size of this. Like, it's so dense, but if I make it less dense, it just gets harder, having tried that previously. Let's see here. Let's try the Zig Zag Mask. This isn't... Oh, that's what was happening. Okay, I get it. Everything is going off of the same width and height, which is 1024 by 1024, which means that's why that wasn't working. So I need something that is the same thing. I could reuse this, but I don't think that's gonna... Yeah, it's not really gonna work. So let me go make a 1024 by 1024 thing really quick. All right, so I have this Springiness map. It's just black around the outside. So the outside should not stand up, but the inside should, theoretically. We're gonna see really quick how well this works. So if I start this, go to our scene. Yeah, looks like there's a few... Oh, right. So the UVs, is that right? It might be. So our UVs, I kind of changed it. They're all based off of world 0, world point 0. So I would have to move this back to the origin for this to align theoretically. But we get these like nice cut swaths of grass cut right through it. So all we would need to do to kind of do this, or to work with this, is change the springiness map when we want something to stay down, and then change the orientation when we want something to kind of shift, actually physically shift. And that shouldn't be too hard, I don't think. So we are going to need some way to actually add forces here. And we're going to need some way to like detect when something actually hits this stuff, which that's going to be a bit hard. But I think I have some ideas on how we can do that. We'll do that next video. But this is sort of where I wanted to get for this one. So I think it's pretty interesting. You can kind of knock things over and they'll stay down, or they'll stand up, or do whatever. So we can knock that over. I can change this so the recovery takes a little bit longer. So maybe you want it just a little bit more tense. That didn't actually work at all. 2 works. 5 probably. I think we maybe... There's some limit we're hitting. Because like these ones didn't stand up anymore. But these ones did. That's kind of weird. I'm gonna... I'll have to look into that, why that's happening. But there definitely is an issue where after a certain amount, it just doesn't stand up anymore. And maybe that's because our floating point values are just getting too low, that we can't actually store, our texture itself can't store the change. So the change is actually too small for our texture to actually have that encoded into it. And since these are only 8-bit values, I don't think that's too hard. Like if these get too small, you're not going to get any feedback. So we may need to tweak that a bit. Theoretically, we could actually assign each individual grass instance its own value. But this, I like this idea more because it kind of works as like most of the classic like editing tools and like splat maps and things like that all would theoretically work a little bit better with this. But we'll play with it some more. I'll have to work on some ideas on how to improve this. But that's where I wanted to get for this video. So yeah, If there's anything you guys want to see, any other ideas you have, let me know in the comments below. I really like any ideas you guys have. If you like the video, hit the like button or subscribe if you want to see more. But that's it for this one. So until next time, see you, Internet.